represent the angle. So the angle definition is equal the amount of rotation. By the way, this point is called a vertex. Okay, vertex. How you measure the amount of rotation? Get the angle. Well. You have, for example, a full circle angle. Okay, something like that. Look. I'm using another color. This is 360 degree. So the full circle is divided in 360 degree portion, and each is 1 degree. 1 degree. We have another important case, the straight angle. Is 180 degree. Okay, and in general we have a quadrantal. This is the name definition, you know. Quadrantal angles is the angle that coincide with is coincident with the axis. Suppose we have the y-axis and the x-axis. Entonces, this is cuadranta. Cuadranta es 0 degree. 0 degree, ¿qué es this? Coma, 90 degree, ¿qué es this? By the way, specifically, 90 degree is called right angle. Coma, 180 degree, ¿qué es this? Que es straight angle. It's also straight and quadrantal. Quadrantal is more general definition, que incluye when the terminal side is coincident with the x-axis or the y-axis. Another guys is 270 degree, que es this angle. And finally, 360 degree. It's exactly coincident with the 0 degree. So the entire full circle. So in conclusion, the circumference is divided in 360 degree. Half of circumference of semicircle is 180 degree. 3/4 is 270 degree. 1/4 is 90 degree. And we have more definition and classification for the angle. For example, when the angle is right angle like that, 90 degree, normally is represented by the small square here. This symbol indicate 90 degree. This is right angle. We have, for example, when the angle is less than 90 degree, so it's in between 0 degree and 90 degree, like that, is acute. Angle acute is 30 degree, 45 degree, 60 degree, 75 degree. It's in between 0 and 90 degree. Obtuse is when it's in between 90 degree and 180 degree. It's like that. It's a big one. Okay, this angle is obtuse. That's the classification: full circle, semicircle, right angle, acute, and obtuse. Okay, and extremely important que the standard position of the angle is, look, the standard position is, we have the axis. Remember the definition, the general definition of the angle have initial side and terminal side. Okay, the initial side is always coincident with the x-axis. So one angle is like that. This is the initial side. And the other, the terminal is in another position, like that. This is a standard angle, in which the initial is coincident always with the x-axis. By the way, this guy is obtuse. Well, now the direction of the angle. For example, the direction is, you see I select counterclockwise the direction, counterclockwise. When the situation happens, if the angle is positive. For example, suppose hypothetically, this is 50 degree. However, we can using clockwise, and when it's clockwise, the angle is negative. Okay, suppose one angle like that. Suppose that this angle is 30 degrees, but in this case, see the direction is in this direction is negative 30 degrees because it's clockwise. Clockwise negative es the convention, guy. Counterclockwise es positive. Ajá, entonces, bueno, profesor, but you can represent this angle like that, or you can represent this angle, for example, like that. It's the same, but in this case, it's 330 degree positive. Because 330 degree plus 30 is 360 degree. Okay? So you can, so there are no infinity, but there are many ways to express one angle. Using negative direction, personally, I don't like negative direction. Using positive direction is always counterclockwise. Entonces, this angle is 330 degree, plus 30 is 360, right? Okay, this is the idea for the angle. In the navigation and astronomy, we're using another unit for the angle. Case, look, let me show you. Another way to express the angle is using minute and second. But this minute and second is not the minute and second that frequently you know of the time in the watch, in the clock. No. It's 1 minute, it's 1/60 degree. 1/60 degree is 1 minute. And 1 second is 1/3600 degree. Okay, it's like you take 1 degree, because, by the way, 1 degree is too small. And you divide this in 60 portions, small portion, tac. And this division is 1 minute. And you take 1 super small minute and you divide in 60 portions also, is 1 second. Okay, so I want to explain how we convert, for example, in one problem is giving the GPS position and the Earth and the Google Earth. You can find the position of any point in the planet, and you will need to navigate from one point to another point. So in the navigation, maybe using ship or airplane, is given the position in minute, second, and degree. Suppose this example. Suppose that we have example 1. We have 31 degree, 47 minute. This is the notation that we use for the minute, is prime, and 12 second, double prime. That means that this is the angle. So suppose that this is a planet. It's the Earth, right? There's one position here. It's the latitude. Latitude is the angle formed by the point and the equator. This is the equator. Okay, this angle is this. 31 degree, 47 minute, and 12 seconds. How you transform it in decimal of the degree? Easy, easy. You put 31 plus 47 divided by 60 plus 12 divided by 3,600. And the answer is 31, it's obvious, 0.7867 degree. So how you transform it using this notation, gets using in navigation, gets degree, minute, and second to decimal of the degree. Okay, and Bauer, suppose que I'm doing Bauer, is relatively easy. You, for example, you take that number and you take the decimal part, is this, and multiply by 60 in order to get the minute. In this case, 47 point something, 47.22. And you take again the decimal part, is 0.22, and multiply by 60 again, and give me 12.2. Entonces this is equivalent to say 31 degree, 47 minute, is this part, and 12 approximate second. Do you understand this, or is confusing?
I didn't understand.
You didn't understand, no? You don't understand?
The last part.
The last part. Okay, let's do another example. Look, 94 degree, 17 minute, and 44 second. Convert to degree. It's super easy. You put 94 plus 17 over 60 plus 44 over 3,600. You put in a calculator like that. And the answer is 94.2956 degree. This is equivalent to this. This is in the notation, a special notation for the navigation, degree, minute, second, and this is just decimal of degree. So you are doing Bauer. You want to see what is the procedure in another sense. You take the decimal part, que es 0.2956, and you multiply by 60. The answer is 17.736. And now you take again the decimal part, que es 0.736, and multiply by 60 again. And the answer is 44.16. How you form it? Well, it's a 94 degree, get the whole part. You take the whole part, get 17 minutes, and you take the whole part, get 44 seconds. Got it? Got it?
Yes, Professor.
Yes.
This is one possibility. I explained that because when you see in the Google Earth or in the navigation system, you see a minute and second. But normally we are working in the degree and decimal of the degree. Okay, another way to express the degree is using radian. Guy, I can erase the board?
No, Professor, can you go back and take a picture?
Take a picture.
Thank you, Professor.
Pleasure. Okay, now another way to express it, the angle is using radians. And radian is the way que es preferred en cálculos. En cálculos, any trigonometric function is expressed using radian. Let me explain radians. Before explaining the radian, I want to explain what is the R length. Suppose we have a curve like that. Yeah, I need to find the length of this R, one portion of the curve. This is R length definition. Okay, you know, it's a little bit, the red part is a little bit curvy. Where you stretch and you see how many centimeters or how many miles have this segment, okay? So using this idea, when you have a circle, when the hour curve is no curve, you know, it's a circle, like that. Let me try to do my best. Circle. No good. A circle, okay. A circle. This is the axis X and Y. Ajá, entonces, one radian is exactly the length que es coincident with the radio. This distance is the radio. Look. This distance is the radio. 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 And arbitrary, the distance from the center to any point on the circle is the radio, no? This is R. And however, si you discover one R length in which the distance of this hour length is equal to the radio. R length, I want to represent using S. S is R length. S equal radio. This angle is 1 radian. Okay, 1 radian is the measure of the central angle of the circle that intersect, and R equal the length of the radio of the circle. Okay, the formula to find arbitrary, this is a fantastic formula. The formula for finding any R length is equal to theta R. And theta is ese angle exprese en radian. O sea, this is the formula for the R length, guys. S is R length. In the formula of the R length, the angle is expressed in radian, mandatory, no in degree, no, in radian. Okay, now I want to show you how you convert degree to radian and radian to degree. But no, now, the most important is when you, for example, you write 1 radian, 2 radian, and 3 radian, this is this distance, 3 radian is pi. So 3 times is a pi. So 3 radio is pi. Pi, you know, is the irrational number que es 3.14159. And this is irrational que continue forever. So pi is that distance. Sorry, it's 180. In 180 degree, we have pi radian. So 180 degree is equal 1 radian. Pi radian, sorry. Pi radian. Pi radian. Pi radian. So I take advantage this statement to find the formula to convert. For example, theta in radian. I forgot to say que in trigonometric, the letter that we are using for the angle is a Greek letter. Maybe alpha, maybe beta. The most popular is theta. Theta. Theta in radian is equal to theta in degree multiplication by pi and divided by 180. Please copy this formula. Super important formula.
So, Professor, sorry, can you take a picture?
Say again?
Can you zoom it for me to take a picture?
Zoom in.
Yes, Professor.
And likewise, theta in degree, it's the same formula, but expressed in different way. Is equal to 180 degree multiplication by theta in radians over pi. This is 2 important formula que allow us conversion degree to radian or radian to degree. Let's see a couple of the examples to understand very well that formula, no? Example of the conversion radian to degree. So far you are studying two different ways to express it, the angle. The conventional, que es degree, o en navigation use minus second. Bueno, pero es en navigation. But in calculus, we use a new way to measure the angle, que es radian. The definition of the radian is when the arc length is equal to the radius is 1 radian. And we discovered that 180 degree is pi radian. And this is the formula. For example, example 1. Example 1. Well, you convert 30 degree to radian. We're using the formula. What formula? The formula that allows us convert degree to radian is multiplication by pi and divided by 180. 30 degree times pi divided by 180. Entonces now you reduce the lowest term. Divided by 3 is 6. Entonces pi over 6. Okay, 30, you put in the calculator, wait, 30 divided by 180 is 1 over 6. It's pi over 6 radians. In conclusion, guys, 30 degree is equal to pi over 6 radian. Got it? Example 2, 90 degree. Convert to radian. Using the formula. Multiplication by pi and divided by 180. 90 degree times pi divided by 180. Okay, you know, divided by 90 is 1, divided by 90 is 2. Pi over 2. Pi over 2 radians is equal to 90 degree. Different unit to express the same idea. Degree or radian. Degree is countable in physics, in chemistry maybe, in science. And radian is countable in calculus. That is the reason that we need to study both. Suppose, example 3, 135 degree expressed in radian. Well, exactly the same, multiplication by pi and divided by 180. 135 multiplication by pi and divided by 180 degree. And of course, that fraction you reduce in lowest term. In this case, divided by 135 is 3 pi over 4. Where come from that? You divide it by 180 divided by 4 is 180 divided by 4 is 45. So you divide top and bottom by 45, 135 divided by 45 is 3. So you divide by 45 here, divided by 45 here, and divided by 45 here. And 180 divided by 45 is 4. Of course, you can divide, but you express the answer in lowest term, no? Like that. So conclusion, 135 degree is equivalent to 3/4 pi radian. Okay, let's do it in opposite direction. Let's do it in opposite direction. Now I give you the degree or the degree of the angle, sorry, in radian, and we need to convert to degree. Opposite direction, same formula, but in opposite direction. Suppose que es given in calculus, in radian, pi over 3. Pi over 3, convert please to degree. Well, the formula is clear. The formula is multiplied by 180 and divided by pi. So I put pi over 3, multiplication by 180, and divided by pi. It's obvious that this pi cancel out, and 180 divided by 3 is 60. Conclusion, 60 degree is equal pi over 3 radian. Okay. Another example, suppose 5 pi over 3 expressed in degree. Well, this is 5 pi over 3, the multiplication by 180 and divided by pi. Always happen that this pi is cancelled. 180 divided by 3 is 60, I did before, multiplied by 5, 300. 300 degree. The conclusion, 5 pi over 3 is equal 300 degree.
Professor, can I ask a question?
Go ahead.
So, Professor, it doesn't matter what we're going to find. You know, cancel something.
Hey, I don't understand. Slow down.
I said it doesn't matter what we're going to find. We need to cancel out something. For example,
Yes.
this one is cancel out the P, the one that
Yeah. See, the angle gets given in radian is like a function of pi. You cancel out the pi. It's obvious, yeah. Si es en décima, no. En décima, no. Okay? Okay, one more. Suppose que given 2 pi over 3. I want to express it in degree. So the thing we are learning now, guys, is conversion. Radian to degree, degree to radian. That's it. And this is the most important formulas. You divide 2 pi over 3 multiplication by 180 and divided by pi. Pi is cancelled, is 120 degree. Because 180 divided by 3 is 60, times 2 is 180. So 2 pi over 3 is equal 120 degree. Okay, the thing that we need to learn, don't try to find another thing. I promise that we study more detail of this. But it's basic conversion. Degree to radian or radian to degree. Good?
Yes.
Good? Because I want in this moment to present to you 2 pictures. Let me erase the board. I can erase the board?
Yes, Professor.
Let me try. Pictures. Okay. Stop. Here. Okay. Okay, look at that. Little by little, I know that you cannot memorize everything today, but little by little, you need to memorize this unit circle. Little by little, little by little. So this angle is 0 degree. This angle is 30 degree. This angle is 45 degree. This angle is 60 degree. And this angle is 90 degree. Okay, it is most important in the first quadrant. Quadrant 1. In the second quadrant, okay, is increasing 30. 90 plus 30, 120. This is the angle 120 that belongs to the quadrant 2. 90 plus 45 is 135 degree. This angle. And 90 plus 60 is 150 degree. 120, 135, and 150 belong to the second quadrant. And the second quadrant is in between 90 and 180. Quadrant 2. Quadrant 3, you increase in plus 30, 130 plus 180 degree plus 30 is 210. So this angle, let me erase that part. This angle is belong to the third quadrant, look, 210. Where come from this 110 is 180 plus 30, no? 180 plus 45, 225 here. And 180 plus 60 is 240. This belong to the third quadrant. And in the fourth quadrant, well, we have the quadrantal. Quadrantal is 0, 90, 180, and 270. And we continue in the quadrant 4. Is 270 plus 30 is 300. This angle is 300, look. In the positive direction, of course, no? 270 plus 45 is 315. And 270 plus 60 is 330. Like this, in the fourth quadrant. One possibility is measure in that direction. This is negative 30 degree because it's clockwise. This is negative 45. And this is negative 60. In the fourth quadrant. In the first quadrant, this is 30, 45 positive, and 60 positive. Okay? My intention is that little by little you are familiar with this number and you little bit understand this. Okay, I have another picture. That's important to show you. This picture. Okay, this picture is in Radian. Look, in Radian. Compare this and this. Okay, we practice a little bit. For example, this is pi over 6, get 60 degree. Look, 60 degree here. 60 is here, 60. And radian is pi over 3. Here, 30 degree is pi over 6. Pi over 4 is 45 degree. Okay, let's do the conversion. The formula is 45 divided by 180 multiplication by pi. It's the formula to conversion degree to radian. And when you divide 45 divided by 180, in the calculator is 5 over 4. Okay. For example, this 225. Okay, it's this angle. 225 degree divided by 180 multiplication by pi is 5 pi over 4. Where come from 5 pi over 4? When you reduce and lower term this fraction, no? Okay, in this case, you divide by 45. So 45, you can verify in your own calculator. 45 times 5 is 225. 1, 2, 3, 4, and 5. And 180 is this guy. Are you clear how we convert degree to radian? Because radian is a little bit weird, no? Degree is more clear, at least for me, no? And radian is a little bit weird, no? Let's do one more. Suppose 150. 150 degree divided by 180 multiplication by pi. Cancel out this, divided by 3, f5 pi over 6 is this guy. This angle belongs to the second quadrant. Make sense or no? Huh?
Professor, I have a question.
Please go ahead.
Yes, Professor, instead of us converting, we need to memorize all of them.
Yeah, little by little. Okay. Listen to me. You need to memorize more than this. Okay. In the next email, I will send the cheat sheet for the trigonometric. The fantastic cheat sheet. Okay, you don't need to memorize anything. You can see, but the process, little by little, you get the idea. Because the professor of calculus you need to, by memory, say that. Okay? So I do not enforce you today or next month to memorize this long information. This is the confusing part of this subject. Okay? And suppose it's similar to the multiplication table. Everyone memorized the multiplication table in the elementary school, no? And this was a process. Little by little. This is my intention. You memorize the angle, and you memorize more things, identities. Okay, I want to explain in your moment. No. Okay, sorry. This is the complicated part of the class. There are people who need to take this class 2 times and 3 times. Okay. Any question about the conversion degree to radian or radian to degree? Suppose another example. Suppose it's given this angle in radian, 2 pi over 3. I need to express it in degree. Well, you multiply by 180, it's completely opposite operation, and divided by pi. It's opposite of this. Pi is cancelled. 180 divided by 3 is 60, times 2 is 120 degree. Clear or confusing?
Clear.
Clear. Okay. Let me try to explain another thing. Yes, it's the last part. It's coterminal. What is coterminal angle? Coterminal is, find the coterminal. This is important, extremely important. Find the coterminal. Coterminal angle. Okay, suppose we have 420 degree. Oh, 420 degree is bigger than 360. So it's more than one full circle. So I need to find the coterminal. Coterminal is you subtracting 360, que es a full circle. Subtracting 360 degree. When you're subtracting 360 degree, you have 60, no? Yeah, it's 60. That's mean, look, let me show you. Our angle is 420 degree is one revolution, que es 360 degree, and 60 more here. Entonces, ¿cuál es the coterminal? O sea, this angle is equivalent somehow this angle. This is 60 degree coterminal, and this is 420 degree. Do you understand the idea? You need to find one angle acute, of course, acute. So in the first quadrant, lie in the first quadrant, have the same terminal side of this given angle. This is the given. Given is 420. I need to find one easy, small, acute, que have the same terminal side. This is important when we study the trigonometric functions. In the trigonometric function, you need to find the coterminal, because the trigonometric function for the 420 degree is equal the trigonometric function of the 60 degree. We study trigonometric function next time, not today. Today is basic angle. Okay? Okay. Let me try another example. I want to complicate a little bit. Suppose this was example 1 is given. Example 2 is now negative 120 degree. Entonces I need to find the coterminal. Wow, 120 degree. Negative angle is, remember, is no counterclockwise, es clockwise. Entonces si es clockwise, es en that direction. It's a 90 degree. And this is a little bit more, 30 degrees, so 90 plus 30, a 120, no? Here, I suppose. And in that direction is clockwise, negative 120 degrees. So what is my goal? Well, my goal is find the coterminal angle, but using the positive direction, so in that direction. Well, it's easy, because basically is 360 degrees, que es the full circle, minus 120. Es 240. Entonces, en conclusion, 240, que es in the positive direction, and negative 120 degrees is the same angle. And therefore, they are coterminal, because share the same terminal side. Make sense or no? Make sense or no?
Yes, Professor, can I ask you a question?
Go ahead. Question.
So, Professor, what do you mean by coterminal angle?
The prefix co indicate equal, and terminal is terminal side. When you talk about coterminal, it's two angles that share the same terminal side. Okay, in the example 1, the terminal side was this. And the second example, the terminal side is this. Because the problem is, the confusing part is that they are not one unique way to express the angle. Entonces, we have no infinity, we have a lot of possibility, but I need to find the easy way. What is the easy way? In my opinion, the easy way is acute angle and positive angle. Okay? So I try to convert this. It's clear, Miss? Coterminal, what mean that?
Yes, it is. Thank you.
It's clear. Okay. Now, let's move on to the example 3. And example 3, I need to find coterminal, 400 degree. But I can see, wow, 400 degree is bigger than 360 degree. Entonces, in my mind, 400 degree is one revolution like that. It's 360 plus something. Entonces, how you find that? When you're subtracting 360, it's 40. Suppose a huge number, and you subtract 360. And again, continue greater than 360, you subtract 360 several times until you get one angle that is less than 90 degrees in the first quadrant. In this case, I subtract it only one time. But suppose another big number, I put 20,000 degrees, subtracting 360, minus 360, minus 360, until you get one number less than 90 degrees. Okay? Entonces now, the coterminal, okay, this is the terminal side. But the coterminal is 40. Is 40 degrees. Entonces, conclusion, 400 degree and 40 degree are the same angle because have the same terminal side. Okay, one more. Example 4. This is important in the future. 750 degree. Wow, this is too large. So say I have no idea. You subtracting 750 using my calculator minus 360. Okay, 750 minus 360, always 360 is 390 degree. And 390 degree is bigger than 360. So I continue subtracting several times, minus 360. And the answer is 30 degree. So what is the interpretation of this? The interpretation is this angle, que is 750, is 2 revolutions. Look, one revolution is 360. Another revolution is, I suppose, que is 720. And continue 30 degree more. Here. This is the terminal side. Now I discovered that one easy way to express it, 750 degree is 30 degree. And this is the coterminal angle. I use it in the rest of the semester. I don't use in this stupid guy. No, I use in this case easier. Because actually 750 is 2 revolutions. So 2 revolutions is 360 times 2 is 720. Okay, 360 times 2 is 720. And we have 30 more, que is 750. Make sense now? More clear now?
Yes.
Clear now, yeah.
I have one question.
Go ahead.
Will the answer ever be negative?
No, the answer is positive. In this case, like, well, you can, okay, any angle you can express it using positive degree or negative degree. Okay, in this case, for example, if you travel clockwise, this angle is minus 330 degrees. Because 330 plus 30 is 350, que one revolution. But no, I don't like this. I like positive. Okay, I like, when you find coterminal, I find positive and acute angle. It's the nice. So I have an ugly, I need the nice. I don't want to complicate my life, negative 330 degrees. Make sense?
Yes, thank you.
Eso, bueno. Okay. All right, now let's do exactly the same idea, but now in radian. Coterminal and radian. Suppose que it's given in radian. Guy, it's the last example. Because I have another class, you need to finish and prepare everything for the next. Let's continue next time. So now, suppose que I have 22 pi over 3. 22 pi over 3. Y I need to find the coterminal. Coterminal. Entonces you subtracting, okay, what's the idea for the coterminal? Subtract 360, no? Maybe you convert to degree and subtract 360, or no, you're subtracting one revolution que es 2 pi. Entonces es obvio que es 20 pi over 3, ¿no? 22 minus 2 is 20 pi over 3. 2 pi, sorry. Hello. This is wrong. You subtract 2 pi. 2 pi. Si you subtract 2 pi, the least common denominator is 3. It's 22 pi minus 6 pi. And 22 minus 6 is 16 pi over 3. And now you're subtracting again 2 pi. A similar idea. You subtract 360, que es one revolution, and you subtract 2 pi, que es one revolution. 2 pi is one full circle. 2 pi in radian, 2 pi. Entonces we have 16. LCD is 3, 16 pi minus 6 pi is 10 pi over 3. Wow, too much. Subtracting 2 pi again. 10 pi over 3 minus 2 pi. Is 3. Is 10 pi minus 6 pi is 4 pi. Wow, 4 pi over 3. 4 pi over 3. And you know that you stop because 4 over 3 is less than 2. 10 divided by 3, no. And 16 divided by 3, no. So you stop here because 4 divided by 3 is less than 2. So you are, in this case, let me see. Si you want to convert to degree to understand much better, you divide it by, multiply by 180 and divide it by pi. The pi is cancelled, as always happen. 180 divided by 3 is 660, and multiplied by 2 is 240 degrees. Okay, the 240 degree is equivalent to 4 pi over 3 and belong, by the way, to the third quadrant. Okay, so in this example, the original ugly angle 22 over 3 represent one revolution, because you subtracting 2 pi, 2 revolution, you subtracting 2 pi again, 3 revolution, wow, because you subtract 2 pi, and when you finish, you lie in the third quadrant here. Actually, it's 3 revolution, and after, in the last 4 revolution, you stop into 40. Make sense or no? Confusing or clear?
Clear.
Clear, it's the same. Okay, basically, entonces we're using coterminal And when you study trigonometric function and give me one stupid angle, 22 over pi over 3, no, I don't find this. I find the coterminal, que is easier, que 4 pi over 3, and you determine the specific trigonometric function that we need. Guys, I enjoyed the class. You are the best. The only thing is you change my background. Let me fix it that. I don't like this forest. Okay, guys. See you Tuesday. Remember, Alex, sign in and Alex using financial aid code free. The student can have the account using the same account.
Thank you.